Hey guys, and welcome back to the Learn C++ tutorial series. Today we are going to talk about functions. Now, one big difference in this video compared to what we've done in the past is I'm actually going to split this into two parts. The first part is going to be a little more formal, talking about definitions, exploring what a function is, and what are the different parts of that. Some different things that you can do with those functions, and really make sure we have a strong grasp of the concept before we actually jump into the second part, which will be coding a small project that's going to utilize some different types of functions to do some different things. So with that said, let's jump right in. These are the five portions of the five features of a function that we're going to talk about here today. The first one's the return type, the function name, parameters, function overloading, and recursion. So what are the different parts of a function? Well, this right here in this box here, this is a function. This is a function that takes in a value and returns the square of that value by multiplying it by itself. Just for some definition, you remember in data types we talked about different types. This is what the return type of this particular function would be. In this one, it's an integer. Within the parentheses here, you have what are your parameters. This is what the function may utilize to run whatever type of change or manipulation it may be needing to run. You have your return keyword at the end here that tells you what value, once all of your code has run, what do you want to shoot back to whatever called on this function. To talk a little bit more about return types, imagine we have this square function in just basic mathematical terms. A is equal to B times B, right? And so this would be also known as B squared. In this line of code here, this takes B times B, takes that value and assigns it to A. Now imagine if we took that same formula, but instead we ran it through a function. Again, thinking back to mathematical terms, so the function of B is going to return that value. Exactly what you would imagine a function is in mathematics is exactly what it is in programming. It's something that takes some sort of input, does something with it, and returns that. Now, sometimes it won't be returning anything. That's when we would be using the void data type, which we talked about in our primitive data types video. In this particular instance, we're returning an integer, that is the square of whatever the input value is to this function. So now we can reimagine this a equals f of b as a equals squared of b, and squared meaning this function that we've built. Squared of b is evaluated. Remember, we start with our r value on the right-hand side of the equal sign. This is evaluated, and then that value is stored in the variable a. You can also do this with more than just integers. We could have a float that returns a float square, a double that returns a double squared, a short that returns a short squared. So you can kind of see the picture here. We can change this function depending on how we need to utilize it in our program. A couple notes about naming your function. So looking back at this function here, you can see it's named squared. So you have your return type, the name of your function, and then whatever your input parameters are. You have your curly braces, whatever code, whatever changes, whatever you're going to do, and then an ending curly brace. An important thing about names is to try and be specific. You don't want to use keywords that are used elsewhere, such as return or main or any other C++ keywords that you're going to use throughout. You want to have something that is descriptive of what your function is designed to do. So if you have a function like ours called square, it's better to call it squared rather than sq. The reason for that is if you come back to use this code later on, you may forget exactly what that code is supposed to do. So this gives you a little bit more of a description of what you're trying to accomplish. Next, we're going to talk about parameters. So parameters are passed into functions to be used or manipulated. Parameters can be of any type, but they must be specified. So for example, a couple slides ago, I showed you that the parameters for squared could be int, but they could also be a float, they could be a double, they could be a short. These could be object types, vectors, and arrays. Really anything that you may need to pass in. Pointers is another big one and super common, which we'll get into that at a later date. But any type that you can imagine can actually be a parameter as long as it's a valid data type. They can also be templated, and again, we'll cover that in a future video, but what I mean by templated is that I could create a function that instead of only taking ints or only taking floats or only taking doubles, I could actually have it take any data type you may give me and still function. And so that's one of the things that makes these functions very powerful. So you can see I could have squared with one parameter. You could also have more than one parameter. So let's say you want to multiply two numbers together. You can have parameter 1, parameter 2. You can see the code still creates this output, parameter 1, parameter 2, and then returns an output. And that brings me to another piece that I want to talk about, which is scope. So one thing to keep in mind is anything that you declare inside of your function, any variable that you define within your function or declare within your function is only going to work inside of your function. So for example, you can see here after our declaration here, we have int output equals param1 times param2. Well, once I leave this function, once I return the output and I get down here, I could no longer type output +1 or output +2. The code doesn't recognize it anymore. This actual variable here only exists within the function that we're running. Interesting about that is when you look in the memory, this actually saves you space in memory. So for example, if I wanted to get a value out of this multiply function, but I don't need to save it, I just need to display it and get rid of it. Well, now I don't have to declare additional memory outside of this function to save that value. And as soon as this function stops running, it will release the memory that it saves for this output variable that we created. Function overloading. So this is nice whenever you have a function where you're not sure 100% how many variables you may need. For example, let's say we want to have a multiply function, but we don't know if we're going to be provided with an int, a double, a short, and so on. For some reason, I wrote double twice here, but in this scenario, you can have a function with the same name, and as long as the return types or the parameter types are different, then we could have different functions for these. So you see I have these two here. These could actually both exist in the same program. We could also have, oh, I see what I did here. So double multiply, you can see here we're passing in both doubles. But let's say maybe I want to double and I want to multiply it by some integer, right? Well, here that wouldn't work. But if I also declare this, now multiply will know what to do if I pass in both a double and an integer, which is going to be to multiply them both into output and then push it out. Something else I want to quickly point out here. So in this initial multiply function, one thing I didn't consider is that the parameter 2 is an integer. And what happens when you operate on two data types that are different is the compiler is going to see this integer and it's going to downgrade this double to an integer as well. Now the problem here is, let's say we have the double 15 and the int 15.5 and the int 2. Well, the expected result would be 21. And that would be correct, except here, because of this integer in the parameter, this double downgrades to an integer, and so you end up with 15 instead of 15.5 times 2, and you end up with 30. And the way we fix that is through what's called casting. So we can cast from one data type to another. Now it's not defined for every possible data type, but for the more common arithmetic items like doubles and shorts, it's well defined. So what we would do is use a function called double, and all we would do is pass parameter 2 into this function called double, multiply it by parameter 1, which is already a double, and that would give us our expected output. The important part of this is that the function signature, return type, and parameters differ with each definition of the function. Recursion. So this is another piece that you'll see show up a lot, and this is the idea here is to make things easier. Instead of typing out over and over again what needs to happen, or maybe you need something to happen over and over again. That's recursion. It's a function that within that function it calls itself, and this is going to make more sense in just a minute. Couple things to note: you should always have a base case that ends the recursion. Otherwise, you get an infinite loop that just keeps running and running and running and running until your computer runs out of memory and freaks out on you. When the nested function is called, the function that called it, the initial function, actually stops and runs the internal function. And now that I'm saying it out loud, I'm realizing with words this doesn't make sense. So let's jump into some visuals. So we know what a factorial is. A factorial is a number that you multiply by one less than itself over and over and over again to get the value. So for example, 5. Factorial 5 is 5 times 4 times 3 times 2 times 1 equals 120. If we wanted to do 6, it's 6 times 5 times 4 times 3 and so on. So we can actually write this function in this manner. We have int factorial. We're going to take an input integer here. The first thing we're going to do within this function is we're going to say if the input is less than or equal to 1, then we want to just go ahead and return the input from this function. So what do I mean? Why would we do that? Well, once we get to 1, we don't want to multiply by 0 because that's going to take it away. And factorials don't do that. You don't multiply by 0. So instead of calling factorial again and passing in a lower value, we want to just go ahead and return 1. Otherwise, we're going to return the input, which is this input right here, times the factorial of input dash 1, input minus 1. So the goal here is just to walk through this. We put 5 into the input. It's not less than 1, so we skip this line. We go to else. We're going to return the input times the factorial of input, which was 5 minus 1, so factorial of 4. And if you look here, you can see 4 times 3 times 2 times 1. Well, that is the factorial of 4. So we're doing 5 times the factorial of 4. Well, once that goes in, now you have 4 here. It's going to repeat, and it's going to do it over again. So we start off with int factorial 5. We return 5 times factorial of 5 dash 1. And this is what I mean by the program pauses. It hasn't quite returned yet. Instead, it's going to start running this internal program. Does it again, does it again, does it again, does it again. So you can see we've come in, it's worked down 5 times factorial of 4, 4 times factorial of 3, and so on. Once it gets to this base case, now we start actually returning values. So we return a value, we return the value of 1 and multiply it by 2, which was our input at that point of the program. Do it again, 3 times 2, 4 times 6, 5 times 24, 120. And that's ultimately what our return value is going to be on the finalization of this factorial call. So that's the basics of how not factorial. Well, it is the basics of how factorial works. It's all of how factorials work. But this is the basics of how recursion operates in most programming languages, and more specifically in C++. So in the next video, the part 2 to this, we're gonna make a calculator, that allows you to add, subtract, multiply, and divide. So we're going to have separate functions for each of those. We're going to have to handle some errors because we're going to have to worry about such as dividing by zero or invalid input. Maybe we won't want to take negative numbers. We're also going to be dealing a little bit with user input. So this is why I wanted to divide this up. So hopefully this has been informative to you, and look forward to seeing you next time where we're going to build this little calculator and get a program that's functioning and running. Thanks again, and I will see you next time.